Welcome back, ladies and gentlemen. You've been told to find R. So you've been told to find R, the radius of this smaller circle. So this diagram, you've been told this is a rectangle, meaning all the angles are 90 degrees, and you can see the radius of this quadrant. So if it is a quadrant because you've been told it's a rectangle, so it means here is 90 degrees, here as well is 90 degrees. So it means these are similar quadrants, each of radius 5 centimeter, because if from here up to here is 5 centimeter, then automatically from here up to here is also 5 centimeters. So what do? We will have to write it in a manner that we are able to determine R. So if you write it in this manner, remember any line from the center. Remember, if you take this quadrant, if I label this point A, point B, point C, point D, then we have maybe this point is X, this point is Y. So if you take the quadrant ADX, that quadrant, any line from the center to the circumference is the radius of that quadrant. And remember, the radius of this quadrant is 5. If here is 5 centimeter, then this length is as well 5 centimeters. So it means from D to this point, if maybe you left this point to be point E, then it means from D to E is 5 centimeter, because it is the radius of that quadrant which is given to be 5 centimeter. And from the center of this small circle, if you let that center to be A, from the center to the circumference of this circle is the radius R, and from E to D is the radius of the quadrant which is 5. So it means from O to D will be 5 minus this R. So this length will be 5 minus R. Then again, from the center to this point here, if that angle there is 90 degrees, is the radius of the smaller circle, that will be R. Then you can see these two quadrants are similar, so it means they will actually be intersecting in the middle of this rectangle. So this length 8 centimeter is divided into two equal parts into 4 by 4. So if you look at this, if you let this point to be F, then you can see the triangle OFD is a right-angled triangle. So we can actually use Pythagoras theorem. So if you use Pythagoras theorem, A squared plus B squared is equals to C squared. So the two shorter sides, you can let this side to be A, this side to be B, then the longer side hypotenuse to be C. So if you do the substitution, A squared will be 4 squared, then plus B is R, so that will be R squared to be equals to C is 5 minus R, so that will be 5 minus R squared. So if you simplify that, 4 squared is 16 plus R squared to be 5 minus R all squared. You can use quadratic identity. When you expand that with quadratic identity, you will have 25 minus 10R plus R squared. Now, positive R squared will cancel on either side of the equation. The R squared will go with R squared. So what do we remain with? We will remain with 16 on the left hand side to be equals to 25 minus 10R. So what we can do? We can add 10R on either side of the equation. So if you add 10R on the other side of the equation, then we'll remain with negative 10R and positive 10R will cancel out. So we'll remain with 10R plus 16 is equals to 25. So when you subtract 16 on the other side of the equation, on the left hand side we'll remain with 10R to be equals to 25 minus 16, which is 9. Then for us to get R, we simply divide both sides of the equation by 10. So you end up getting R to be 9 over 10, which is 0.9. Then the units you've been given there is centimeters. Ladies and gentlemen, that is one of the means of determining the radius of that given inscribed circle. If you have another simpler means of determining this radius, then feel free to leave it in the comment section. Thank you for watching, and see you again in our next presentation.